Hello, Math 1050. This is Mrs. Bricky. Section 4.1 is on inverse functions, and there are 4 topics. Some functions have an inverse. We've talked a lot about functions this year. Not all functions have an inverse, but a lot of them do. An inverse function is a function that reverses or undoes the action of the original function. So if you have a function f and it turns an apple into a banana, then the inverse function would turn a banana into an apple. For a function and its inverse, the values of x and y are interchanged. So this tells us that the domain of the original function is the same as the range of the inverse, and vice versa. The range of the inverse is the domain. The range of the function is the same as the domain of the inverse function. X's and Y's for these two types of functions are switched. If a function is 1-to-1, then it does have an inverse function. If a function is not 1-to-1, then it does not have an inverse function. So there's a relatively easy way to test if a function is 1-to-1, and that test is the horizontal line test. So a vertical line test tells us if a function, if a relation is a function. A horizontal line test can tell us if that function has an inverse. So here are 6 graphs. We have to just decide if they are 1-to-1 or not. So look for spaces where it would fail the vertical line test or the horizontal line test. So this one's a no. We've got an issue in here, so also a no. But this one looks like I could pass that horizontal line over the entire function and it would be fine. So this one is a yes. It is a 1-to-1 function. Over here we've got definitely a no. And here we have a no. But this last one, it looks like we could pass a horizontal line over that relation and it would be 1-to-1. So this last one is a yes. So to test if a function is 1-to-1, use the horizontal line test. If you look at a graph of a function and its inverse, you can see that the x and the y values are interchanged. So like right here, I've got the 0.52 on this function, and I have the 0.25 on its original function. So literally the x and the y values just switched. And you could check another point and you'd see that same thing happening. This is the 0.21. If I look on this graph, it goes through the 0.12. The x and y is literally switched. So, here's a point. Another example, 1, 0. The inverse goes through the 0.01. The x and y are switched. You might also notice like the symmetry that you can see on these graphs. When you look at that or think of that diagonal line as like a mirror, the two sides are a reflection of each other. So our next topic is to graph the inverse of a function if you're given its graph. So this little 2-piece graphed function is function f. Our job is to graph f's inverse. The easiest way to do this, the strategy to use, is to think about the endpoints and any sharp turns that the function has, and you can either list them or just think about them. On the inverse function, those x and y values will be switched. So if the original function goes through -6, -3, the inverse will go through -3, -6. If it goes original goes through -5, 5, the inverse will go through 5, -5. I'm just switching the x and y values. And if the original goes through 8, 7, the inverse will go through the 0.78. So if you graph those, you should see that symmetry that we talked about. If you looked at the line y equals x, that diagonal line, you should see that the inverse that you graphed is a reflection of that original function. So I would check for that symmetry before you hit submit. Okay, our next topic is finding, evaluating, and interpreting an inverse function for a given linear relationship. So our equation that we're going to be working with is right here. So scientists have found the relationship between the temperature and the height above a distant planet's surface follows this equation. The temperature equals 48.5 minus 2.5 H. So this equation allows us to calculate the temperature at a certain height. So I'm going to kind of write that down. Our T function calculates temperature at a given height. So our first question is, if T inverse is the inverse function for T, which of these statements best describes it? Well, T calculates the temperature at a given height, so T inverse would calculate temperature. I'm sorry. T calculates the temperature, so T inverse would calculate the height at a given temperature. They're switched. The x and the y switched. So in this one, we calculated the temperature, that was the y, using height x. So in this one, we calculate the height, which is our y value, given the temperature is our x value. So that would be this first statement. T inverse gives us the height above the surface when the temperature is x degrees Celsius. These other choices don't really work. This next one down actually describes T. T calculates the temperature at a height of x or a height of h. The second one that we didn't choose, the ratio of temperature to kilometers, that one's definitely not it. And the last one, the reciprocal of the temperature, that one's not it either for sure. Okay, so now that we have selected the correct statement, our next part asks us to find the inverse. Now, I've mentioned several times that inverses and functions have switched their x's and y's, and that's the procedure we're going to use. Switch the x and y, and then solve for y. That will be our inverse. So maybe this feels a little awkward because we don't have an x and a y. The function's value is the y, so this part is the y, and our h here is our x. So if we switch those, this is going to be x equals 48.5 minus 2.5 y. So we switched the x and y. The independent became the dependent. Now we need to solve for y. So I would start by subtracting 48.5 from both sides of my equation. So I now have the equation x minus 48.5 is equal to negative 2.5y, and then I would divide by negative 2.5. It's okay to leave your function in this form. It does want you to use an x, not an h or something. So it does prompt you to put it in terms of x, t inverse of x, and you can leave it in this form. You could divide it, but I would just leave it in this form. We have one last follow-up question. Part C is going to have you use your inverse to calculate a particular value. So it asks us to calculate the t inverse of 33. So we're going to sub 33 into our function. T inverse of 33 is equal to 33 minus 48.5 divided by negative 2.5. So if I calculate that, I get 6.2. And T inverse, if you remember from our context, T inverse gives us the height above the surface when the temperature is X degrees Celsius. So this means 33 degrees Celsius. That temperature corresponds to 6.2 kilometers above the surface. Okay, our last topic is to find the inverse of a rational function, which is quite tricky. Definitely more challenging than finding a linear inverse. Um, it's going to ask you 3 questions in this topic. It's going to ask you to find the inverse function. So our function here is g. We're going to find g inverse. It asks you also for the domain and range of the inverse function. So for the original function g, it has a domain, of course, and it has a range. So the domain of our function right here, it's a rational function, so we just have to check to make sure we don't have any division by 0 happening. So our domain would be from negative infinity to negative 3, and from negative 3 to infinity. The range of these types of functions is a lot more tricky to find, so I'm going to leave that blank for now, but it has a range. For the inverse function, it of course also has a domain and range. But remember that the domain represents x values and the range represents y values. So if we're thinking about g and g inverse, the range of g inverse is the domain of the range of g is the domain of g inverse, and the domain of g is the range of g inverse. The x's and y's literally switch. So even without finding g inverse, I know its range is going to be from negative infinity to negative 3 and from negative 3 to positive infinity. So if I were you, when I do this topic, the very first thing I would do is fill in the range of the inverse, which you can get from the domain of the original function. Okay, so we've filled in our range of our inverse, but now we are going to calculate or figure out algebraically what the inverse is. So here are the steps for finding g inverse. We've got some fractions here, so our first step is to clear the fractions. We're going to be distributing a little bit, and then these 2 steps are key. Collect the y terms on one side and factor the y out. So here we go. Switch the x and y. So this is our y value, so that becomes x. And those 2 x's on the right become y's. And so this is why it's a little bit challenging, is that the y right now is showing up twice in our equation, and we need to sort of get it so that we have y equals something. So we've got to get those y's together. So our first step, so we switch the x and y, solve for y. Our first step on our list over here is to clear the fractions. So we're going to multiply both sides by y plus 3. And that x is timesing by both of those terms, both the y and the 3y. So I'm going to apply the distributive property. That's xy plus 3x is equal to 5y minus 9. Okay, so key step number 3, collect all the y terms on one side. It really doesn't matter which side you decide to go to. You just need to pick one. I think because this 5y, I mean, it doesn't really matter. Let's subtract the xy. And then let's add the 9. So everything that has a y, I'm moving to the right, and everything with no y, I'm moving to the left. So this term is gone and this term is gone. So what I have now is 3x plus 9 is equal to 5y minus xy. So I've gotten all the y's on one side. Now the reason you want to get all those y's together is so that you can factor out the y as the GCF. These 2 terms have a y in common. And then we are almost done. Our last step is to divide. We're going to divide by 5 minus x, which gets that y alone. So our inverse function g inverse of x is 3x plus 9 over 5 minus x. So we would type that in as our inverse function. Something to note here is that you and your neighbor could be doing exactly the same problem, and you could have a slightly different looking inverse. That's okay. It kind of depends which side you decide to go to. They'll be similar, but they can look slightly different. So don't panic if you're like, mine looks different. Even if you're doing the same problem. Okay, our last step to find the domain of the inverse. The domain of the inverse we can figure out because the only real issue that will come up is that we can't divide by 0. So our input cannot cause 5 minus x to be 0. So that is a domain restriction of x equals 5. So our domain for our inverse function would be from negative infinity to 5 and from 5 to infinity. Everything is fine. Any x value is okay except 5 causes division by 0. All right, so that is it for section 4.1. Thanks a lot. Let me know if you have any questions.